past decade, cloud computing has been gaining popularity at a tremendous rate. Some cloud providers are experiencing a growth rate of 50% year over year, which is just astounding. And the reason for this growth is obvious. Cloud computing enables ubiquitous, convenient, on-demand access to a shared pool of configurable computing resources, which can be rapidly provisioned and released with minimal effort. Microsoft Azure is a cloud computing platform that offers a broad set of global compute, storage, database, analytics, application, and deployment services that help organizations move faster, lower IT costs, and scale applications. The Azure Resource Manager provided by Microsoft Azure is a versatile service that simplifies how you manage your cloud resources. The Azure Resource Manager can help you define, build, and maintain your application in a consistent manner. Within the context of Azure Stack, the Azure Resource Manager is the management layer, API, where you connect to for deploying resources. With Azure Resource Manager, ARM, you can deploy, delete, or update all resources for your solution in a single and coordinated operation by using templates. The templates are in form of JSON format, and these templates can be used for deployment in different environments, such as staging, testing, and production. The Resource Manager helps in providing auditing, security, and tagging features to help you manage your resources post-deployment. Although we have the Azure portal for managing the resources, but in case where you need to maintain and deploy multiple servers in complex configurations, it might get cumbersome to handle these deployments and configuration activities via the point-and-click portal. Moreover, remembering every resource category and their respective cost evaluation can become a mammoth task. As companies look forward to automating deployment, scaling, and operations of cloud applications in the Azure cloud across clusters of hosts, there's a need for providing automated deployment for the cloud infrastructure. With Azure ARM Templates, you can define your infrastructure environment in simple JSON file template. These file templates can be versioned, validated, and checked into your source control systems. This is what we call infrastructure as code, IAC. Do you know what it takes to design and deploy sophisticated cloud applications and manage your complex infrastructure via the use of ARM templates? How does one go about automating the configuration of the cloud resources in the Azure cloud environment? How to make the deployment process consistent and repeatable? How to scale the infrastructure with a simple push of a button or a simple command? These are some of the fundamental problems cloud and DevOps engineers struggle with on a daily basis. This course teaches you how to design, deploy, configure, and manage your Azure cloud resources with Azure ARM templates. The course will start with an introduction to the Azure ARM templates and their core features. Then we will dive deeper into designing and deploying our cloud resources with the use of these templates. If you are serious about building scalable, flexible, and robust Azure ARM templates for deploying your cloud infrastructure, then this course is for you. These DevOps and cloud computing skills are in high demand, but there is no easy way to acquire this knowledge. Rather than rely on hit and trial method, this course will provide you with all the information you need to get started with your Azure cloud projects. Startups and technology companies pay big bucks for experience and skills in these technologies. They demand DevOps and cloud engineers to automate the deployment of their cloud resources. And in turn, you can demand top dollar for your abilities. Do you want the skills and be highly sought after? Do you want your career to touch cloud 9? Did you answer absolutely to that question? If so, then our new training program, Azure Crash Course, Manage Your Azure Cloud with ARM Templates, is for you. My name is Arsh, an instructor at tetratutorials.com. We have been in the software industry for more than 2 decades. We've been part of many prestigious projects and startups. Over this span, we have gained great insight into what makes for flexible, scalable, and robust software and IT solutions. We are passionate about sharing all our collective knowledge with you. In this course, Azure Crash Course Manage Your Azure Cloud with ARM Templates, you will get an overview at how to utilize Azure ARM Templates for designing and deploying your Azure Cloud resources in a consistent and repeatable manner. You may be a cloud veteran or an enthusiast. If you invest your time and bring an eagerness to learn, we guarantee you real, actionable education which will set you up on the path to become a cloud engineer or consultant. We are confident your investment in time with us will come back to you manyfold in no time. So if you're ready to make a change and learn how to build some cool ARM templates in the cloud, click the Enroll Now button below. You're still not convinced? Fine. What if I told you that you risk nothing by enrolling in the Azure Crash Course, Manage Your Azure Cloud with ARM Templates? The course comes free of cost. Absolutely no credit card required. Zip, nada, nothing. Look, if you're serious about becoming an expert cloud engineer and generating significant income for you and your family, it's time to take action. Imagine getting that promotion which you've been promised for the last 2 presidential terms. Imagine getting chased by recruiters looking for skilled and experienced engineers by companies that are desperately seeking help. We call those good problems to have. Imagine getting a massive bump in your income because of your newly acquired in-demand skills. That's what we want for you. If that's what you want for yourself, click the Enroll Now button below and get started today with our Azure Crash Course, Manage Your Azure Cloud with ARM Templates. Let's do this together. Hello everyone, and welcome to this Azure Crash Course, Manage Your Azure Cloud with ARM Templates. In the past decade, cloud computing has been gaining popularity at a tremendous rate. Some cloud providers are experiencing a growth rate of 50% year over year, which is just astounding. And the reason for this growth is obvious. Cloud computing enables ubiquitous, convenient, on-demand access to a shared pool of configurable computing resources which can be rapidly provisioned and released with minimal effort. Microsoft Azure is a cloud computing platform that offers a broad set of global compute, storage, database, analytics, application, and deployment services that help organizations move faster, lower IT costs, and scale applications. The Azure Resource Manager, provided by Microsoft Azure, is a versatile service that simplifies how you manage your application and infrastructure resources. Whether you are a developer, an IT professional working for a client or company, the Azure Resource Manager can help you define, build, and manage your application in a consistent manner. Within Azure and Azure Stack, the Azure Resource Manager is the management layer, API, where you connect for deploying resources. Azure Resource Manager is a template-based management service. These templates are based on declarative JSON syntax, and they're called Azure Resource Manager templates. In this course, we will give you an overview of this handy management feature, ARM Templates. You will get hands-on knowledge about how you can use them to automate IaaS and PaaS deployments. We hope you enjoy this course and find all the information we're sharing useful. Let's get started. Here's the overview of the course modules that we'll cover. We'll begin with a general introduction to the course. We'll then move on to an introduction to Microsoft Azure ARM Templates. This module will give you an overview of ARM templates, their structure, and the benefits of using them. We'll also walk you through a demonstration on how to deploy an Azure ARM template. Next, you'll learn all about the different features and deployments offered by ARM templates and how you can use them to perform various tasks. You'll learn how ARM templates are used to automate Azure IaaS and PaaS deployments. In light of the key topics you just saw, what can you expect to learn from this course? Well, here are the key learning outcomes expected from this course. By the end of this course, you will understand the benefits of ARM templates, list the components of ARM templates, explain the key features and application areas of ARM templates, and improve your project and career prospects in general. Microsoft Azure ARM templates are extremely flexible and powerful, and they're used for management and deployment of Azure cloud deployments. At tetratutorials.com, we focus on in-demand skills and real-world education. Gaining this practical knowledge and experience with Microsoft Azure ARM templates will be very valuable for your career. And it'll be a right step towards improving your work or project or career prospects. The more in-depth knowledge you have about Microsoft Azure ARM templates, the more marketable and more sought after you will be. It's a lot of fun and exciting stuff coming in this course. We hope you are as excited about it as we are. Before we move forward, let's examine why Azure Resource Manager is such an important topic to learn. Cloud computing platforms and infrastructure are complex to manage, and Microsoft, along with other cloud vendors, are constantly trying to provide tools and frameworks to make this administration easier. Azure Resource Manager is such a service. Azure Resource Manager is an essential tool in an experienced cloud engineer's tool belt. Azure Resource Manager is a one-stop shop solution for all your resources. You can deploy, manage, and monitor your resources as a group all in one place. One of the biggest advantages of Azure Resource Manager is the ability to repeatedly deploy your solution each time with minimal effort and complete confidence that your resources will be deployed consistently. The Azure Resource Manager provides excellent features and tools that help you optimize processes and save operational costs. Tagging options and customized policies are just few of these exciting features. Azure is a comprehensive set of cloud services that help you build, deploy, and manage applications. Its versatile tools support you in efficiently building anything from simple mobile apps to internet-scale solutions. And this is what has made Azure the preferred partner for a number of massive and global organizations such as Bank of America, Heineken, 3M, GE, Citrix, and so many more. Its versatility and range of products makes Azure the platform of choice across industries, geographies, and functions. Before we get going, let's talk about some housekeeping items. To download all the resources used in this course, please navigate to http://go.tetranoodle.com/Azure-ARM. Here, you will find all the relevant code used in the demos. And you will also find the slides for this course. So if you haven't done that already, please navigate to the URL listed above and download all the resources to your local machine. After you've downloaded the slides for the course, you can review them from your local system even when you're offline. And you may want to download the code if you plan to follow along with some of the upcoming demos. As you've already seen in the course overview, this course has been designed to contain a blend of theory and practical examples and demonstrations to help you take what you learn and directly implement it in your day-to-day jobs. The real-world scenarios and walkthroughs covered in this course will help you understand concepts in a way that is applicable to your projects. The introductory modules will give you a bird's-eye view and understanding of ARM templates. This lays a strong foundation for us to then deep dive into the ARM template components and how they can be modified and implemented. Finally, you will move on to learn how you can automate IaaS and PaaS deployments using the Azure ARM. We hope you enjoy this course and find it instrumental in your work and business practices. I will see you in the next lecture where we'll dive into the introduction to ARM templates. Hello everyone, and welcome to this section of this course on Microsoft Azure ARM. In this section, you will get an overview of what ARM is, what ARM templates are, and how you can use them. The Azure Resource Manager is a new way in Azure to deploy and manage all the resources for your applications. What was previously a tedious process where you had to use multiple services or applications to manage your resources has now become much more accessible. The Azure Resource Manager, ARM, is templatized and provides you with a single platform where you can view, develop, modify, and deploy all your cloud resources as interdependent parts of a single entity. In this section, you will get familiar with Azure ARM templates and their basic structure. By the end of this section, you will be able to understand basic cloud computing concepts, describe the Azure Resource Manager, and outline the basic structure of an ARM template. So, what are we waiting for? Let's get started. Let's begin with a fundamental concept as it pertains to Azure, which is cloud computing. Let's first understand what cloud computing is. Wikipedia defines cloud computing as a kind of internet-based computing that provides shared processing resources and data to computers and other devices on demand. Or, in other words, we can say it is a computing model in which large groups of remote servers are networked to allow the centralized data storage and online access to computer services or resources. As we already alluded to, cloud computing adoption is exploding throughout the world. Let's understand why that is so. Here are some of the main benefits and driving forces behind cloud computing. Cloud computing allows companies to avoid upfront infrastructure costs and focus on the projects that differentiate their services and products. In the recent years, this has enabled technology startups to invent and come up with innovative technologies and products without worrying about spending a lot on upfront fixed infrastructure. Cloud computing allows enterprises to get their applications up and running faster with improved manageability and less maintenance. Cloud computing enables IT to adjust resources to meet fluctuating and unpredictable business demand more rapidly. Major cloud providers are vastly trying to use renewable energy sources to run their data centers, and they're also coming up with more efficient data center designs to reduce energy consumption per unit of the computing resource. And this obviously has tremendous advantages for the environment. Since cloud providers can manage their data centers more efficiently and cheaply, these savings can then be passed on to the cloud consumers. The availability of high-capacity networks, low-cost computers and storage devices, as well as the widespread adoption of hardware virtualization, service-oriented architecture, and atomic utility computing have led to a growth in cloud computing. Companies can scale up as computing needs increase and then scale down as demands decrease. Cloud computing has become a highly demanded service or utility due to the advantages of high computing power, cheap cost of services, high performance, scalability, accessibility, as well as availability. Some cloud vendors are experiencing growth rates of 50% per year. Cloud computing services are typically provided in three different service models. Infrastructure as a service, IaaS, and this is the most basic cloud service model. And under this model, the cloud provider offers computers, physical or more often virtual machines, and other resources. IaaS refers to online services that abstract the user from the details of infrastructure, like physical computing resources, location, data partitioning, scaling, security, backup, and so on. Platform as a service, PaaS. PaaS offers a development environment to application developers. In this model, the cloud provider typically develops toolkit and standards for development and channels for distribution and payment. In the PaaS models, cloud providers deliver a computing platform, typically including operating system, programming language execution environment, database, and web server. Some examples of PaaS are AWS Beanstalk, Azure Websites, etc. Software as a service, SaaS. In the software as a service or SaaS model, users gain access to application software and databases. Cloud providers manage the infrastructure and platforms that run the applications. SaaS is sometimes referred to as on-demand software and is usually priced on a pay-per-use basis or a subscription fee. Some examples of SaaS are Google Apps, Microsoft Office 365, etc. Before talking about what Microsoft Azure ARM does, let's understand the need for a tool like Azure ARM. An application's infrastructure is usually made up of a number of components, such as virtual machines, virtual networks, web applications, database servers, storage accounts, and third-party services. Although these are different entities, you don't see them as separate components, do you? You will see these as different but related and often interdependent parts of a single entity, that is, your application. And since they're all interdependent, it would make sense that you would want to deploy, manage, and monitor them as a group. Now, currently, you may be doing this using different services or platforms, which makes managing all these components a difficult and tedious task. And that is where the Azure Resource Manager comes in. The Azure ARM allows you to work with all of these components of your application as a group. You can use the Azure ARM to deploy, update, or delete all the resources for your solution in a single operation. Let's look at some of the features and benefits of the Azure ARM. The Azure Resource Manager allows you to use predefined, structured templates for deployment. These templates also work for different environments such as testing, staging, and production. Additionally, Azure Resource Templates are all based on JSON syntax. This means that they are JSON files and therefore follow the same syntax and structure as a JSON file. Azure ARM templates define resources you need to deploy on Azure. What this means is that depending on which template you choose, parameters like what the resource looks like, what configuration they will have, etc., are all captured by the Azure ARM templates. For example, if you want to create a virtual machine, you can simply use an Azure ARM template to create an Azure virtual machine. Furthermore, you can manipulate the configuration of the virtual machine at a very granular level. Like, add the virtual machine to an availability set, determine the location of the virtual machine, whether the virtual machine will use any extension, what storage account that virtual machine will use, and on and on. The Resource Manager also provides the added benefits of security, auditing, and tagging features to help you manage your resources after deployment. And you can interact with the Azure ARM from the Azure Management Portal, REST API, PowerShell, and Azure CLI. Here's a tip that you must take into account. When you deploy the ARM templates using Azure PowerShell or Azure CLI, you must first create a resource group and then deploy the Azure ARM template within it. If you don't know what a resource group is, don't worry. We're going to define it shortly. If you're new to the Azure Resource Manager, there may be some terms that you're not familiar with. So we're going to quickly go over these terms and what they mean. Let's start with resources. A resource is a key component of an Azure ARM template, and it's basically a manageable cloud item available through Azure. Some examples of resources are virtual machines, storage accounts, web apps, databases, and virtual networks. There are a lot more types of resources, and as you start using the Azure ARM, you'll discover what they are and how you can use them. Next, resource groups. A resource group, as the name suggests, is a type of container that holds related resources for an Azure solution. What goes into a resource group is entirely up to you. You can add all the resources for a solution, or you can choose to add those resources that you want to manage together as a group. The choice is yours. You can decide how to allocate resources to resource groups. Let's take an example of an organization that has an HR, finance, technology, and business domains or verticals. Now, since all departments of this company use Azure, they need a way to distinguish between each and every vertical and their data. And to do this, the company assigns each vertical a resource group. Now, each vertical, let's say HR, will deploy all their Azure resources in the same Azure resource group. This makes it very easy for the business owner to see the usage of Azure from each vertical and then act on it. So you know what resources and resource groups are, but where do these resources come from? A resource provider. A resource provider is a service that supplies deployable resources that you can manage using the resource manager. There are many different resource providers in the market, each with their own set of offerings and unique operations needed to work with various resources. Some of the common resource providers that you may have heard of are Microsoft.compute, which supplies the virtual machine resource, Microsoft.storage, which provides the storage account resource, and Microsoft.web, which supplies resources related to web apps. And now let's talk about the primary topic of discussion of this course, the Azure Resource Manager template. That's a JSON file that defines one or more resources to deploy to a resource group. It also defines the dependencies between the deployed resources. You can use the template to deploy resources consistently and repeatedly. And finally, you will also need to use declarative syntax, which makes your life so much easier. You can use declarative syntax to state what you want to do and avoid the hassle of having to write the code to create it. A great example of this is the Azure ARM template. You simply use the template to define the properties of the infrastructure to deploy to Azure. Okay, now that we got the fun stuff about the definitions out of the way, let's try to understand some of the benefits of using Microsoft Azure ARM. So let's talk about why should you use the Azure Resource Manager? And to understand this, let's have a look at its many benefits. Firstly, it's template driven. We have already briefly discussed this. You can use ready templates to deploy all your resources. It's multi-service. This means that you can deploy, manage, and monitor all the resources for your solution as a group, rather than having to handle these resources individually, which is tedious. It is idempotent, This means that you can deploy your solution over and over and over and over, and did I say and over again, without affecting the current state of resources, and with the confidence that your resources are deployed in a consistent state. It's declarative, thus allowing you to declare which resources you want to have and manage those resources only, rather than having to work with an imperative system where you have to make the rules and write the scripts. It also allows you to define dependencies between resources, so you can control the order in which they are deployed. It's a multi-region tool that lets you choose which region you want to deploy the resources in. It also gives you the benefit of access control and tags, which let you control all the services and logically organize them as you see fit. As you can see, Azure Resource Manager has these benefits that make it easier for you to deploy and manage your solution. Now that we understand that, let's dive into the structure of an ARM template. It is time to dissect the code. Let's discuss the basic structure of an ARM template. An ARM template contains the following elements. The schema. This is what defines the basic layout of the template. Content version. As the name suggests, this just specifies the version. Parameters. These are values that are needed for deployment. Variables. These are custom variable values we create within the ARM template. Resource. As we've already seen, these are one of the components of an Azure ARM template. And output. This is what you use to return data and objects from a deployment. Now, let's look at an example of an empty resource template. It looks something like this. At the top, you can see the schema file. The schema file consists of the schema where the actual definition of how a template is going to be is defined. The content version, as we just discussed, is used in the deliverable to control the code delivery and to maintain its version. Parameters and variables are values that can change depending on the template and requirements. Parameters contain values that you can take from the user, whereas variables are values that can be generated within an Azure ARM template. Resources are used to define all the resources that you want to deploy in Azure. And output is what is given after the template is executed. So now that you have an understanding of the basics of the Azure ARM templates, its components and elements, let's quickly log in to the Azure portal and take a look at the templates. Now that you have an understanding of the structure of an Azure ARM template, let's take a look at the real thing in Azure itself. In this demonstration, you will walk through an Azure ARM template in Azure. In this demo, you're going to take a closer look at how ARM templates look in Azure. So let's start by logging in to the Azure portal. Now, as with most other Azure services, there are multiple ways to create an Azure ARM template. And one of the quickest methods is using the portal itself. But before we dive into creating an Azure template, let's first take a look at an existing Azure ARM template. This will give you an idea of how deeply embedded these templates are and how they're interconnected to make your job that much easier. To do this, first, click Virtual Machines. Here, you can see we have deployed one virtual machine already. Click the virtual machine listed here, that is WinDC1. Looking at this page, you can't tell that this virtual machine was created using an ARM template. So how do we make the connection between Azure and this virtual machine? Well, scroll down and click Automation Script. This displays the Azure ARM template that deploys this specific virtual machine. You can see that this template is very specific to this virtual machine and has values that have been defined specifically for this VM. What this tells you is that most resources in Azure have this automation script that allows you to see the whole environment that you've created in a nutshell in the Azure ARM templates. This should give you some insight into how deeply Azure ARM templates are embedded into the Azure system. Now, click Overview. All the values and settings that you can see on this WinDC1 machine panel can be defined by an Azure ARM template. Now that you've seen how deeply Azure ARM templates are embedded within the Azure system, let's take a closer look at a schema of an ARM template. With new Azure features being released regularly, the key thing you need to understand is how the schema stays updated with new properties and resources in conjunction with the ARM template. To do this, let's create a demo Azure ARM template. Go back to the main dashboard screen. Click More Services, and here let's search for the keyword templates. Okay, here in the search results list, let's click templates. And this will show you a list of all the ARM templates that you can deploy. And since you're creating a demo template, let's click on Create Templates. Now, what Azure Portal will do is open a code editor within the browser for you to write your template code. So let's allow a few moments for the code editor to load. Okay, this page allows you to enter all the information and code needed for a new ARM template. In the name field, type your template name. For this demo, we're going to get really creative and enter demo template. In the description field, enter a brief description of the template that you're creating. For this demo, again, very creatively, we're going to enter demo template for testing. Amazing. And once you're done, click OK. The next step is adding an Azure ARM template. You can see here that there is some basic default information about the ARM template. This is basically mandatory information that is needed irrespective of what type of template you're creating. Now let's take a closer look at the schema of this template. So copy the schema link and open it in a web page. Oh jeez. Wow, this is cryptic. There is no way that we can make sense of this extremely cryptic text. In fact, what you see here is multiple JSON files that are part of this schema. In order to visualize it better, let's copy these JSON files and open it in your editor of choice. We will be using our IDE of choice, Visual Studio Code. Let's paste all the JSON code that we copied from the web page. And now, save the file as a JSON file on your machine. This automatically converts the script into JSON format. Now the script you see here is not serialized. So let's give you a quick tip on how you can make this more readable. Simply right-click on the script and click Format Document. Isn't that much better? So now you can see this is a JSON schema, which is very similar to XML schema, but written in JSON format. Now, when you scroll down and view this file, you can see that there are a number of templates here that are mapped to different services on Azure. There are templates for virtual machine scale sets, and even virtual networks. So what you can observe is that this main schema refers to other service-specific schemas. Here's the template for virtual machines. What you see here is that the JSON template that was included in your Azure ARM template contains this URL with this schema that links to all the schemas of all the resources on Azure. Let's say you want to create an Azure virtual machine. Let's review the schema specific to virtual machines. So copy this VM template schema link and open it in a browser. Copy the JSON code and paste it into Visual Studio Code and format the document as you did before. Now, you can see here that this schema contains definitions for the ARM template for Azure Virtual Machines, Azure Compute Environment, as well as extensions. Basically, it contains all the definitions that should be presented inside a virtual machine. Let's review this node called Definitions. Here, you will find all the definitions for specific items which may be present inside a virtual machine. Let's take an example of the OS disk. The OS disk has a number of properties defined, such as name, VHD, image, etc. Along with the property name, you also have specific data types for each property, like this property called name is of type string. Furthermore, in JSON schema parlance, some of these properties are also using the ref pointer. The whole idea of this is to use a URL to specify a pointer to a given section of a JSON document. Here, what it is saying is that the data type of VHD is defined at a separate location within this document with the pointer value of definitions/VHD. Let's have a look at another property called create option. Here, this property is defined as an enumeration. As such, it can have a value of from image, empty, or attach. So, okay, I've given you all this information. How is this useful, you may ask? Like any other schema, it formalizes the contract for the final template document. This schema can help us validate the target document and also provide some additional features. For example, our IDE can use these schemas to provide you code completion or code suggestions. When you go deep into creating Azure ARM templates, you may need to refer to this schema to know where a specific property of your Azure resource lands in the ARM template. For example, if you didn't know that OS disk should be present as a property within the ARM template, how would you be able to deploy it? You can never be sure of the schema until you see it yourself from the schema URL. As you've just seen, the Azure portal is a great starting point for using the Azure ARM with just your browser. All you need to do to use the Azure ARM templates is to create resources using the Azure portal. While this browser-based code editor is very handy, it may not be scalable to meet all of your requirements. At some point, you may need to write a deployment template that describes all the resources you want Azure ARM to provision. And to be scalable, this deployment will need to be automated. You can do this using one of many available IDEs or tools that will allow you to create and edit JSON templates for ARM. You can use tools like Notepad, Microsoft tools like Visual Studio and Visual Studio Code, or Sublime Text. In this section, we got an overview of Azure ARM Templates. We took a closer look at all of the components of ARM Templates and what their functions are. You also got a sneak peek into what ARM Templates really look like and how to identify its various components. We have loads more in store in the next section, where you'll gain a deeper understanding of ARM Templates and all the features it has to offer. So make sure you join us back again in the next lecture. Thank you guys. I will see you then. Hello everyone and welcome to this section of the Azure Crash Course, Deployment of ARM Templates. In the last section, we got an introduction to ARM templates and their components. You gained an understanding of what ARM is, what ARM templates are, and how you can use them. In this section, we'll look at some of the more complex and in-depth features of the ARM template. So what are you waiting for? Let's get started. In this section, we will dive into taking a closer look at Azure ARM template components, some of the key features and different deployment options available in Azure ARM templates. By the end of this section, you will be able to differentiate between single and nested templates, describe incremental and complete deployment modes, list key Azure IaaS and PaaS templates. Let's go. To deploy your solution, you can either use a single template or the main Azure template with multiple nested Azure ARM templates. Nested Azure ARM templates are common for more advanced scenarios. Using a nested Azure ARM template gives you the following advantages. They allow you to break down your solution into targeted components. You can reuse nested templates with different main templates. Now this is a great feature as it allows you to create modular Azure ARM template code that can be reused for different applications. You can also use parameters to conditionally link to nested Azure ARM templates. When you do this, the parameter becomes a part of the URI for the template. Now, let's look at single templates versus nested templates. The Azure ARM allows you to deploy your solution either as a single template or by distributing the responsibilities as a good coding practice into multiple templates. Why is this needed or even recommended as good coding practice? Well, as you know, our cloud applications, software architecture, and environments are getting more and more complex. With new technologies, apps, and devices constantly flooding the market, what do you think emerges as the primary need? It is the need for solutions to account for multiple advanced scenarios. You have to think of questions like, what if there are sub-environments? How can you manage data better? How do you ensure maximum reusability with less effort? Splitting your template over multiple files can help manage data better and help with readability and organization. You can have a single main Azure ARM template that drives the multiple Azure ARM nested templates. Nested Azure ARM templates are very common for more advanced scenarios, and by advanced scenarios, we mean scenarios where you want to deploy more than one simplistic virtual machine. There may be a bunch of databases, virtual machines, queues, and so forth for a complex environment. Let's look at the advantages of nesting templates. You can break down a solution into targeted components using nested Azure ARM templates. Another advantage is the modularization and reusability of the nested templates and the template code. Now let's move on and see another great feature of Azure ARM templates called the deployment modes. By default, Azure ARM templates have two deployment modes, incremental and complete. The incremental deployment mode is the default mode. In the default mode, it does not remove or modify any existing Azure resources. It just does the incremental deployment of existing Azure cloud resources. This means that incremental deployment mode does not remove or modify existing resources, even if they're not mentioned in the template. In the complete deployment mode, the Azure ARM template will delete any Azure resources that are not mentioned in the ARM template. This is the best option for when you want to start afresh or refactor a solution. Now let's look at some real-time applications of Azure ARM templates. IaaS, or Infrastructure as a Service, is a form of cloud computing where virtual computing resources are provided and managed over the internet. They can easily be scaled up or down based on requirements. These virtual infrastructure components include servers, data centers, virtual machines, storage, and networking hardware. How does this tie in with Azure ARM templates, you may ask? Well, Azure virtual machines and virtual networks are all part of Azure's IaaS offering. So once you create an ARM template, you choose to automate its IaaS deployment. Azure's Infrastructure as a Service, or IaaS, includes Azure Virtual Machines, Azure Virtual Networks, and Azure Storage. These are just the three key services provided by Azure. There are multiple other services such as Azure Disk, Managed Disk, Azure Load Balancer, and on and on and on. But these are the key ones that are used most frequently and widely. Now let's move on to PaaS. Do you know what PaaS is? Well, PaaS, or Platform as a Service, simply put, is a development and deployment model where a provider, in this case Azure, hosts the hardware and software tools on its own infrastructure. This frees users from having to install these tools themselves and allows them to concentrate on the applications themselves. PaaS is designed to support the complete web application lifecycle. So how does this tie in with Azure ARM templates? Well, Azure Web Apps and Services are all part of Azure's PaaS offering. So once you create an Azure ARM template, you choose to automate its PaaS deployment. Azure offers a multitude of PaaS services such as Azure Apps, Azure Functions, Azure SQL, Azure Data Factory, Azure Data Analytics, etc. Some of the key services include Azure Web App in SQL, SQL Elastic Pool, and Azure Web App Service Environment. This wraps up our module. In this section, you learned about nested templates and how they differ from single templates. We covered the different deployment modes available in ARM templates. And finally, you learned about the different Azure IaaS and PaaS services that you can deploy using the Azure ARM. This also wraps up this Azure Crash Course, Manage Your Azure Cloud with ARM Templates. So in this course, you got an introduction to Azure ARM Templates and their features. We started off with the basics of Azure ARM Templates, their structure, components, and how they all work together. You then took a closer look at the different features of Azure ARM Templates and their deployments, such as nested ARM templates and deployment modes. Finally, we discussed some use cases for the implementation of Azure ARM Templates in IaaS and PaaS deployments. We hope you find this information useful in your automation and DevOps projects. We also hope you had as much fun learning about Azure ARM as we had putting together this course for you. Let's stay in touch. You can connect with us directly via LinkedIn, Twitter, or email. We'll be glad to help you out in any way we can. And please do not forget to leave a review for this course. It will really help us and moreover other learners. And last but not least, please do check out other top-rated courses that we are offering. There are many special offers available for you in the last bonus lecture of this course. Please consider it as a token of appreciation for our current students. But wait a minute, there is so much more you can learn about Azure ARM templates. How do you use all of the Azure ARM template components? What are some of the best practices that you should keep in mind? How does template deployment actually work? And what about the different real-time applications of IaaS and PaaS deployments? How do you actually deploy these templates? If you want to learn all this and gain a deeper insight into the inner workings of Azure ARM templates, then join us for the Azure MasterClass, Manage Your Azure Cloud with ARM Templates course. It covers detailed demonstrations, tips, in-depth features, and concepts that will help you take full advantage that is offered by ARM Templates.